All right, today we're going to talk about the sampling distributions of sample means. So what we want to do first is make sure we know our symbols. We have mu, which is the population mean, and we have x bar, which is the sample mean. Okay, so what we're going to do here is talk about the sampling distributions. So those are the samples, the graph. So the graph of all the samples of the mean. So we're going to take all these x bars, X bar, X bar, X bar. Everybody takes a different X bar and we make a graph of that. That's the sampling distribution of sample means. So the mean of that graph, okay, so the sampling distribution of sample means will have a mean, which is mu X bar. That is the mean of the sampling distribution of the sample means. It will also have a standard deviation. So that's the standard deviation of all the X bars put together. And here are the two formulas for that. Okay, so a couple rule of thumbs. First is that we can only use the standard deviation formula if the population is at least 10 times the sample size. And the facts about this are true no matter what the population distribution looks like. So you can always find the mean, you can always find the standard deviation. But those mean and those standard deviations will make a normal distribution only if the population is normal. So let's go ahead and look at our pink sheet again. And if we just focus on the mean part at the bottom. So the mean of a random sample is right here, and there's your two formulas. So we can call this the mean of all the X bars. So this is the mean of the sampling distribution. This is a standard deviation of the sampling distribution, which is population standard deviation over the square root of n. So sigma is the population standard deviation over the square root of n. You can only use this formula. You can only use this formula if the population is at least 10 times the sample size. And the symbol we use for sample size is n. Okay? So this right here will give us the sampling distribution of sample means. So the sampling distribution of sample means will be approximately normal. Ignore that. Sampling distribution of sample means X bar is approximately normal if the population is normal. Okay, and we're going to add to that. Okay, but today we're just going to say we can always find the mean, we can always find the standard deviation as long as population is 10 times sample size. Those two things together make an approximately normal distribution only if the population is normal. So let's look at this example. Again, this example is not in your notes, so you probably want to write down the general ideas for that. So we've got an intelligence score here, an IQ test with a mean of 100 and a standard deviation of 15. Okay, so this thing here is approximately normal with a mean of 100 and a standard deviation of 15. So can we calculate the probability that a randomly chosen individual has a WAIS score of 105 or higher? Sure, this follows from chapter 2. We just have this normal population with a mean of 100 and a standard deviation of 15. So I'm going to go out 15 in each direction. There's one standard deviation out. What is the probability that an individual has a score of 105 or higher? Okay, and we're going to guess that to be in the 40% range, but let's see. We're going to do this as a normal CDF, lower bound of 105 to an upper bound of infinity, comma, a mean of 100, and a standard deviation of 15. We type that in our calculator and we get 0.369, or about 37%. So if the whole population is approximately normal, has a mean of 100 and a standard deviation of 15, the probability that one person selected will have a score of 105 or better is about 37%. Okay, so that's all chapter 2 stuff. We've already done all that multiple times. So part B, what are the mean and standard deviation of the sampling distribution of the average score? What is the mean and standard deviation of the sampling distribution of X bars for 60 people? So your N is 60, and your mean of all your X bars is going to be the same as the population mean, which is 100. Okay, your standard deviation, oops, this should be an X bar. Your standard deviation of all your X bars is going to be the population standard deviation over the square root of N, which in this case is going to be 15 over the square root of 60, which if we type that in our calculator, we get 1.936 or 1.94. So there we have our mean and our standard deviation of the sampling distribution, which you'll notice is different than the mean and the standard deviation of the population. So up top here, this is the population. So we can write, so in part C, we're going to find the probability that the average score for 60 people is 105 or higher. So first, let's talk about why we can use our standard deviation formula. So one thing we need to say here for the standard deviation formula is that we're going to assume the population of adults is at least 10 times 60, which is 600. And for part C, we need to say that the sampling distribution is approximately normal. Why is that? Okay, so this first one, population is at least 10 times the sample. That's so we can use the standard deviation. Now, if we're going to do part C, we need to say that the X bars are normally distributed. The sampling distribution is normally distributed. So if you remember to do that, if the population is normal, then the population is normal, the sampling distribution will also be normal. So here we're going to write the sampling distribution is approximately normal because so the sampling distribution is approximately normal because, how do we know? Well, if we go back, not there, if we go back and look at our definition here, if the population is normal, then the sampling distribution will also be normal. That's what this says here. Okay, so if we go ahead back here, the sampling distribution is approximately normal because we are given that the population is approximately normal. So because we are given the population is approximately normal. Okay, well, I'm totally running out of room. I apologize. So now we can say that X bar, all the X bars are approximately normal with a mean of 100 and a standard deviation of 1.94. So again, at the beginning, we had the X's themselves, the individuals were approximately normal with a mean of 100 and standard deviation of 15. Now we're talking about all the X bars. So the sampling distribution will be approximately normal with a mean of also 100, but a much smaller standard deviation. So how do we calculate that an SRS of 60 people is 105 or higher? Okay, so we want our X bar to be greater than or equal to, doesn't matter how you put it, we need the probability that that is bigger than 105. So, same concept as before. We have a mean of 100. Our standard deviation is much, 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 much smaller. So 105 is now going to be way, way out here. This will be 95. So we want this teeny tiny area there. So we're going to normal CDF, lower bound of 105, upper bound to infinity, mean of 100, standard deviation of 1.94. And you should get 0.005. Okay, so what is the probability that an individual will have a score of 105 or above? That's 37%. What is the probability that an average of 60 people will be over 105? That is 0.5%, a lot smaller because you're taking an average of 60 people. So hopefully that helps you out, and we will do more in class. Have a great day.